Hello folks. Okay, now it's time to talk about Lab 2, where we get some fun and exciting stuff with Bash and get to play with a little bit of C++ for the first time around, and we'll see how we go here. So, let me get rid of this first. There we go. Okay. Basic idea is that first off, in Lab 2, you're going to be pulling some changes I've made to the instructor repository for the project. You're going to merge that in with your own code, and I don't think there should be any conflicts that come out of that, but if there are, you'll need to resolve those. You're going to be writing 2 bash scripts, and we'll talk about those today. And you're going to be editing one C++ file. You're not going to be doing anything too extensive to it. We just want to bring it up to the code standards for the project. So just to make sure that you actually go through the code standards for the project, and also so that, especially for those folks who are new to C++, you get to explore the C++ files a little bit without having to do anything too in-depth to them. So that's kind of the idea on where we're going. I'm just going to walk through the basics here. So again, the first step is that we want to go through and pull the changes that I've made to the repository. So you can do a quick check to make sure that you've set up your remote correctly back from Lab 1, and if not, then you can go back and reset that. You're going to use the git pull instructor master to get the changes that I've made in the master branch for the project. And what you're going to find is that I've added the .cpp file, the C++ file for demo, to that. I've updated the make file so that it will compile based on that new C++ file. And I added a test directory that's got a whole collection of data files in it that we'll get to in, I guess, step 3 of this. It's unlikely you've changed any of these. I guess you might have changed the make file, but if you have, then you'll have to deal with any merge conflicts you get out of this. So once you've done that, do an add to commit, basically saying, okay, I've got to step 1, right? I've merged in the instructor changes. And then we'll get into the meat of the lab. So the first thing you're going to do is create and add a bash script. And the goal for this one is pretty much, I want to make sure that folks write a script that dumps some stuff to standard output, that pipes some stuff from one program into another, and that captures the output of a command and parses that a little bit. So for this first script, there's 3 parts to it. So it's expecting that when the user runs the script, they're providing an optional number of file names. They might provide none, they might provide 1, they might provide 3. Any number is valid. So if the user runs it, your script name is going to be filecheck.sh. So if somebody runs /filecheck.sh and gives some file names, there's a bunch of things it's going to do to each of those files. And it'll go through and do each one in sequence. So it'll do everything for demo.cpp, for instance, and then do everything for item.h. But we want it to go through, and for each of them, it should do some error checking, make sure that it's the name of a readable file, not a directory, and give a reasonable error message if it's not. If it is a readable file, then it should go through, and first, it's going to run git blame and whatever the file name is, but pipe the output into less. And we'll try each of these from the command line in just a moment so you can see what they do. It's going to run head with -n and 5 to display just the first 5 lines of the file, but it'll let the output for that go directly to standard out. You don't pipe that one to less. So this is basically just going to be 2 nice straightforward commands for this git blame file name, head -n 5 and the file name. Or the variable that holds the file name. And then we'll run wc, so this is the built-in command that lets you count the number of lines, words, and characters in a file. Have the script capture the output of that, so you're going to use your, some variable name equal $ bracket, your wc and the file name, and that's going to give you a bunch of words of output that we'll take a look at in a sec, that you're then going to have to go through and grab the number of lines out of that and the number of characters out of that and display that. So essentially you want to go through and give a nice error message saying, okay, here's, or a nice user message saying, okay, for file blah, the number of lines were blah, the number of characters were blah. Don't simply dump wild or WC directly to standard output, right? The whole point of this is for you to capture the output of WC, parse that, and then print out the pieces of information that are relevant. So your first script is going to go through and do essentially that. Maybe let's take just a moment and take a look at what those commands actually do. So again, once you've done your pull and you've set up all your changes and you've done your add and your commit, again, the make file will be in here. Where is it? The make file will be in here, somewhat modified. If you take a look in the make file, if you're curious, again, you'll see that it now has the compilation instructions to build from that .cpp file, which you'll now see in there, and you can take a look in demo.cpp if you're curious and have a look. I mean, this is what you're going to be bringing up to standards. Let's see. So if we do a make, hopefully it rebuilds the demo. We'll play with that in a little bit. But again, these three commands that you want to experiment with, the git, blame, and say a file name, let's use demo.h, and piping it into less. So this is what you want your script to do with any of the valid file names. We'll go through and tell you who committed essentially each line of the file. So not terribly exciting, but it gives you a chance to experiment with git blame. The head command can be used to display the first chunk of a file or the last chunk of a file, or pardon me, just the first chunk of a file. So if we use head-n5 and our demo.h, for instance, it displays the first 5 lines of the file. There's a tail for displaying the last lines of a file if you want. So we'll get your script to do that as well. And the WC tells you how many lines, words, and characters there were in that particular file. So for that one, you're going to be doing in your script something like, WC output equals your $word count demo.h, something like that. So you're going off, capturing the output from the command, and then you're going to be parsing what's in WC out. So here for now, we'll just echo it, and assuming I haven't messed anything up, and it goes through and displays the information. But you're going to be doing something like this to capture it, and then you're going to be grabbing that first word, the 66, and the third word, the 2246, as the number of words and number of lines and characters in the file, and displaying that. So this is what your script is supposed to be doing. You're going to want to make sure, of course, that your script follows the coding standards for the project, right, including all the bash requirements. So you're going to be writing a script that's going to do this as part 1, or I guess part 2 of the lab rather, part 1 being the pull. And then we're going to go through and add our second script. So for this one, it's going to run a bunch of test files. Oh, pardon me. Let me get this right. Yes. This one's supposed to be going through and running a bunch of test files on the demo program. So what I've done is put together a bunch of test files that have commands for the demo program stored in them. And so you can run the demo program taking its input from these files. So let's take a look at some of those just briefly. If you look in your repository under tests, you'll see that there's one file there called just quit that has the command to just simply quit. If you look in the verbose subdirectory, you'll see one collection of commands for just some basic experimentation. So that one would create a new tree, insert an item in it, print the tree, and then quit. Right, so there's going to be a variety of different test cases stored in files in these directories. So tests contains a bunch of directories with a bunch of test case files in them, and for each of them we can run the demo program from, for instance, tests/just quit. Oops, forgot my /. So it runs the program, it's sending the output to standard output, right? So it's just appearing on the screen, but it's taking the input from that file. So what I'm going to get you to do is to write a script that goes through that tests directory and runs the demo program on every test case file it finds in there. So that's going to be the fun part for that portion of the lab. So again, you're going to create, oops, how about our second script called run tests, where it's going to have a recursive function in it, explore, and this is going to be a lot like the kind of recursive function that we discussed in the lectures, where it's going to do a traversal of a directory. So the script prompts the user, please specify the name of the file or the name of the directory that contains all your tests and the name of the executable I'm testing. So the user might type in something like tests and demo. It makes sure that they're both readable and executable, right? Executable because you've got to be able to cd into the directory and you have to be able to run the demo program. And then it passes these off, your script passes these off to your explore function, which begins going through that directory, looking for test cases and running the program on them. So this will be, again, an opportunity for you to write a function that goes through, does a recursive traversal of the directory, running the program on every test file it finds. Again, following the code standards, making sure you do your add and commit for the script. And yeah, good practice with bash, and a good lead-in to some of the test automation that we're going to do later in the semester. All right, and then the last thing you're going to do for the lab is to look at that demo.cpp file, and you're going to edit it to conform to the project standards. So you're going to read through the project standards, you're going to edit demo.cpp, and tweak the layout, tweak the commenting, etc., so that it does actually conform to standards. Now, the idea is you don't want to change the core functionality, but if you need to change things like prompts or error messages or identifiers, you can go through and do that. All right, again, not editing any of the .h files, right? Those are actually, when I test your code, I'm probably going to drop your .cpp file in with my header files to make sure that it conforms to the way the header files are specified, and we'll see how things go. And again, as always, make sure you do your git push origin all to get everything back to the server so I can mark it. Tons of fun. All right, I will leave it there for now.